Hi everyone, I am Dr. Nishok from EC Department, SNS College of Technology. Here we have gathered to discuss the topic Schmitt Trigger using operational amplifiers from the subject linear integrated circuits. So here is the outline of our video. It starts with understanding the real problem in electronic systems, problem statement, brainstorming possible solutions, Schmitt Trigger circuit and practical applications. So what is the real problem in electronic systems? In many electronic systems, we use the sensors like temperature sensor, industrial sensor, etc., which produces the noisy signals, and the input fluctuates near threshold voltage and the comparator output becomes unstable. So these are the major issues in those electronic systems. So coming to the problem statement, normal comparator causes the multiple switching, false triggering, unstable digital output. So these are the main issues in the electronic circuits. So we need to overcome these issues and produce the stable switching, noise rejection and reliable analog to digital conversion. So here is the brainstorming idea called hysteresis concept, so which provides the output in a stable manner with the help of the positive feedback and two switching thresholds. So a system like comparator will use only the single threshold voltage, so which acts as the reference voltage for the input signal. So if the fluctuations is between a small values also will reflect in the unstable output. For example, in a comparator circuit, the reference voltage is 2 volts. So if the fluctuation is between 1.99 and 2.01, so it will reflect in a major instability in the output part. So this is overcome with the help of the hysteresis concept, which uses the two reference voltage. So one is upper threshold point and another one is the lower threshold point. So because of these two reference voltages, output we will obtain the stable output, which prevents the unwanted switching. So coming to the Schmitt Trigger circuit, we can see the operational amplifier along with the feedback resistors R1 and R2. We obtain the stable output signal. So here the important concept is positive feedback concept, which create the hysteresis. The output will switch only between the positive saturation voltage and the negative saturation voltage based on the given input signal, which overcomes the high switching issues. So coming to the Schmitt Trigger waveform operation, the sensors as shown in the previous slides obtain the noisy and analog waveform as shown in the slide here as a triangular input waveform, and the output obtained from the Schmitt Trigger circuit will be the clean square wave. So the noises in the input is rejected with the help of this hysteresis concept, and the final result will be stable switching and rejected noise. So on coming to the practical applications of the Schmitt Trigger circuit, it is mainly used in switch debouncing in digital circuits and sensor signal conditioning and waveform shaping circuit and noise removal in communication system and microcontroller input signal stabilization. So it is the time for summarization. Schmitt Trigger using operational amplifier. We have seen this topic with the main drawbacks of the electronic systems, and which was overcome with the help of the hysteresis concept that used in the Schmitt Trigger circuit and its practical applications. Here are some assessment questions. The first one is Schmitt Trigger converts the analog to stable digital signal. So on the difference between upper threshold point and the lower threshold point is the concept named as a hysteresis. So these are the books and websites we referred for this topic. Thank you all for joining this video.